doctor. You're a doctor in rural Madagascar. And one of your patients comes to you and says, "Hey doc, I think I have malaria." That sounds like the start of a joke. And in Ireland, we don't worry about malaria. But if you did do that, what the doctor would do is take a sample of your blood and put it into a machine called a centrifuge. It's a big lump of metal, costs a couple of €1,000, runs on electricity, it spins the blood around, and we can learn a lot about the blood just by spinning it around. But you're in rural Madagascar. You don't have money, you don't have a centrifuge, and you don't have electricity. What you do have is a patient who needs care now, and a beer mat and a piece of string. Some of you might have heard of centrifugal force. Some of you might even know what it is, but this is how it goes. Newton's first law says that an object in motion stays in motion. If you throw something, it's going to keep going until it hits something. If you want to move something in a circle then, if you want to swing it around, you need to keep stopping it from flying off as it wants to. If you saw Interstellar, they spin the spaceship, and the force that wants to throw you out into space is counteracted by the wall, and it feels like gravity, and you feel like you're back on Earth. You can do the same thing with a centrifuge. It spins really fast, you get the centrifugal force, and it pushes out the more dense particles and the less dense particles. And so you have, say, your red blood cells here and your yellow blood plasma here. This is called a whirligig, and it's a really old toy. It's been found in Bronze Age burials, so that's 3000 BC. I'll show you how it works. It's really easy. I made this one in the pub the other night. Spin it up like this, and you just pull it, and it goes woo, woo, woo. And a team at Stanford realized that these are actually really good at spinning really fast. In fact, they can spin at about 125,000 RPM. That's faster than a commercial centrifuge. If you spin your blood that fast, you can separate out the plasma in about 2 minutes, or you can separate out the eggs of malaria in about 15 minutes. The amount of things you can tell just by pulling blood into a centrifuge is amazing. You can, for example, detect HIV, you can detect tuberculosis. But those machines are hard to get. We have them in our labs here, but in rural Madagascar, very difficult. That thing I just showed you there will function as a perfectly good centrifuge, and it costs about 20 cents to make. You can 3D print them, you can make them out of beer mats, and they're saving lives. They're saving lives right now, because once you separate out all the little bits, you can see there's malaria, there's no malaria, this is a man, this is a woman. You can see all sorts of things. It's called a paperfuge, and it's going to save some lives. Thanks for listening.
What's not to like? Judges, have you a comment?
That's great. Thanks, Danny. That was quite funny. So I suppose, in your position, why do you think communicating about science is really important, particularly for an evening such as this?
Money. but realistically, all of this stuff is really expensive to get off the ground. And if we're going to be, money essentially comes from the government, from the taxpayer. If we want people's money, we have to give them something back, and we need to get people excited about science. And like, we're competing with hospitals and schools and the police for money. And so we want them to know that it's worthwhile, or it's fun, or it's not a waste. I don't want to be a waste of money. That's why.
Well said. Thank you very much.
Well done.